Hey everyone, and welcome to our demo of Mirdi for Teams. So 2 years ago, we launched the Mirdi open source, a development tool that lets you run a local process in the context of a Kubernetes cluster. So it lets you test new code in cloud conditions without going through CI and deployment, and it cuts down your development cycles. If you're not familiar with the Mirdi open source, we've recorded a separate demo for it. There's a link to it in the comments. Today, we're introducing Mirdi for Teams, a commercial offering built on top of the Mirdi open source. And Mirdi for Teams adds functionality that makes it a better fit for teams by adding collaboration, security, and management features. And we're going to showcase some of this new functionality in this video. So to install Mirdi for Teams, you need to install a component called the Mirdi operator in your Kubernetes cluster. This is a persistent component that underlies all the functionality provided in Mirdi for Teams. In order to do what it does, Mirdi open source creates an agent pod in your cluster. With Mirdi for Teams, the operator is the one creating the agents and then routing traffic between them and the clients, which saves you having to give all of your end users permissions to create pods in your Kubernetes cluster. So now we'll install the operator, and to install it, we'll use the Mirdi CLI tool, which we'll do right now using Brew. Great, and now that we have the Mirdi CLI installed, we'll use it to install the operator. Now at this point, if you haven't done it already, you'll need to register for Mirdi for Teams at app.metalbear.co, where you'll get a license key that you need to install the operator. I've already done it, so I'll just run a simple one-liner. And there we go, now the operator is installed. The main value of Mirdi for Teams is that it makes it easier for multiple developers to work together on the same cluster. So I have a demo cluster ready with a service called the IP visit counter, which is an HTTP server with a public endpoint that can receive traffic from the internet. I'm using the JetBrains Golang IDE, and I already have the Mirdi IDE plugin installed. I have the following configuration, which tells Mirdi to steal incoming traffic to the remote IP visit counter and redirect it to my local process, but only if it has the following header. So next I'm going to run a Mirdi session. I'm going to enable Mirdi here and click debug. And I'll select the IP visit counter deployment as my target. And simultaneously, I've asked my coworker to run a session from his local machine on this same cluster. So first, Mirdi for Teams adds a new command to the Mirdi CLI, the Mirdi operator status command. And this gives me a status of the cluster from Mirdi's perspective. I have some details about my license, but more importantly, I can see which sessions are currently being run in the cluster. So I can see that my coworker is running a session on the same deployment as me, and he's using a different filter. So he's using XPG tenant Aviram, and I'm using XPlayground tenant Eyal. Now, functionally, because we have the operator to orchestrate between different Mirdi agents, Mirdi sessions in the cluster, now we can run multiple sessions concurrently on the same deployment as long as they use different filters. So just to demonstrate, I'm going to run a curl command against the public endpoint of the IP visit counter. I've run it with my header, and so I've hit a breakpoint in my local process. I'm going to let that resume. And if I change it to my coworker's header, then it reaches his local process. And finally, if I remove the header entirely, it's going to reach the remote process. So the next feature of Mirdi for Teams that we're going to talk about is called copy and replace. So one of the limitations of Mirdi open source has to do with reading from queues, right? So if you use Mirdi on a local process that's trying to read from a queue and the remote process that you're targeting is trying to read from the same queue, then you're going to compete for those messages and often lose. So to handle these sort of cases, Mirdi for Teams adds a feature called copy and replace. And what it does is it creates a copy of the pod that you're targeting. That copy has all of the environment variables, files, network access, etc. that the original pod has. So when you target it, you can, for example, read from the queue that it has access to. But the copy does not run the process that reads from the queue itself. So it does not compete with you for messages. And additionally, this is the replace part, mirrord scales down the targeted deployment to 0. So your local process can read from the queue unchallenged. And of course, once the session is over, then the original deployment is scaled back up. So to demonstrate, we'll be using a different service in our cluster called the IPVisit consumer. So when I send a request to the IPVisit counter, it enqueues a message to a Kafka that we have running in our cluster, and the IPVisit consumer reads from that Kafka. So to get started, we'll run a session with the IPVisit consumer with the default configuration without using copy and replace. So we'll enable mirrord and click debug. We'll select the IPVisit consumer deployment as our target. Great, so we're up and running. And next, we'll send curl requests to the internet endpoint that enqueues messages to the Kafka. Now, I've set a breakpoint at the point in the code where the IPVisit consumer reads from that Kafka, so we're expecting it to be hit for every curl request that we send. So let's try it out. So no breakpoint. Oh, there it is. And if we resume and try again, no breakpoint, no breakpoint. Oh, there it is. So we can see that we only get some of the messages from the Kafka. So we can stop execution now. And now we'll add a configuration that tells mirrord to use the copy and scale down or copy and replace feature. So we'll get mirrord to generate the default configuration. We don't need all of this. And we'll add copy target, scale down, true. Now we can run a session. We'll use the IPVisit consumer again. And we're up and running. So first we can start sending curl requests. And we can see that we get a breakpoint for each and every one of them. And just to see what happens in the cluster, we can see that the IPVisit consumer has been scaled down to 0 pods. Now when we stop the session, we can see that it's been scaled back up. So we mentioned before that mirrord for Teams is intended for teams to use concurrently on the same cluster. But what if you want stronger control on this? What if you want to enforce who can use mirrord and where and how? So mirrord for Teams offers 2 features to help with this: policies and roles. So policies are a CRD that we've added in mirrord for Teams that lets you control mirrord specific actions like stealing. So you'd be able to limit who can steal traffic and how, and of course on what namespace, what pod, deployment, etc. To demonstrate this, we've created a sample policy that you can see here. And as you can see, what it does is block stealing on the IPVisit counter. So pretty simple. And now to apply the policy, all we have to do is this. And let's test it out. So we're back at the IPVisit counter. We have a steal configuration. So let's enable mirrord, try to run it. We'll use IPVisit counter as our target. And there we go, forbidden, blocked action. In addition to this, Murdy for Teams adds a couple of roles that you can use as part of your standard Kubernetes role-based access control, and control who can use Murdy on what namespace pod or even at all. You can read more about these roles in our documentation. So Murdy for Teams is still pretty new at the time of the recording of this video. It only came out as generally available in January of this year. And we have a lot of cool stuff in the works. So one of these features is called queue splitting. So we mentioned copy and replace to handle queues, but there's still an issue there because you scale down the remote pod, right? So you potentially affect other people using the cluster, which is something that we try to avoid with MirrorD. So queue splitting is an upcoming feature that's going to let you do essentially the same thing as HTTP filtering, but with reading queue messages. By manipulating deployments with the operator, we're going to be able to let you specify a filter and then only receive queue messages with metadata matching this filter, having all other messages be handled by the remote pod. So this is an example of the type of powerful feature that having the operator in the cluster and able to manipulate it lets us implement, whereas with the open source, it would be a lot more difficult. So that was a little bit about MirrorD for Teams. If it sounds of interest to you, you can try it out at app.metalbear.co. There's, of course, a free trial. And regardless, come chat with us on Discord or contact us in any of the other ways listed here in the video. Hope you found this interesting, and see you at the next demo.